Perfect. I think we're set up. So I am live streaming. I've been doing this since before the pandemic. And then the pandemic happened and we did lots of remote learning over Zoom, and watching blank screens on Zoom was stupid. So I'll just keep doing quick. So I still stream on Twitch. I think it's fun. And then if you're sick, you don't come, because I have 7 children and get enough germs at home. So please don't come if you're sick. Attend remotely, or you can watch the recordings on YouTube after the fact. It is officially an experiment. It is not officially supported by the school, just FYI. I should always have Wi-Fi, but if the Wi-Fi dies, I'll do my best to hit the record button if I notice. So you might miss a few minutes here or there, but usually it works out pretty well for folks. So if you like coming in person, great. I'll be here to answer questions. If you like being remote live, just chat on Twitch. I usually try and keep chat up on the other screen here. And it should be a lot of fun. So, hi, by the way, I'm Eric. Nice to meet you. If you haven't Googled me yet, I'm the only Eric Chinesky in the world. Not too hard to find me. I've got my own page here, which was fun to put together. It's got my different courses. I teach at OCC as well. Technically full-time there, part-time here. It's been a lot of fun. Still do software engineering. I keep busy. I like all sorts of games, tabletop role-playing games. Lots of fun with Dungeons & Dragons. My kids seem to enjoy it, or they humor me. So we have fun there. Other links and stuff about me, sure. It's not too interesting. So we'll talk about the syllabus, and then we'll get into a quick sprint through the basics of C# that is really just some of the syntax, because this is a language elective for you folks. So you've done some programming before, at least through 200, I think, right? So you've had 2 semesters of coding already. So the first chapters are real quick. We'll just take a look at what it looks like in C#, some of the cool stuff you can do in C#, and then we can go from there. I'm a big fan of GitHub. I don't think Canvas is for code, because it's not. Code just is absolute garbage in Canvas, and I don't want to have to download stuff. So I'll talk you through all that. It's a lot of fun. It's a little bit of a learning curve using GitHub, but Git itself is the most widely used source control tool in the industry. GitHub happens to be a hosting provider of the Git source control tool, and they give it away for free for educational use, which is fantastic, and for open source use and all sorts of other things. So we'll make extensive use of Git. You'll turn all your code in there, and then all you do is give me a website URL where it is on github.com when you turn stuff in, and then we can see the code on GitHub, and you don't have to attach files to Canvas, and life is good. We'll talk about that. Twitch link here. I do have a Discord server that I run if you like Discord. It comes to my phone, so if you want to message me there, that's really easy for contacting me. You've got my cell phone number in the syllabus here. I didn't put it in the GitHub repo. If you Google me, you can find my cell phone number, but I wanted people to at least work for it rather than just find it here. So I think I have pretty much a copy of the syllabus here in the GitHub repo. So all the code examples I do in class will go to the GitHub repository here. So if you want to see the code we did in class, it'll be out here, which is awesome. I don't have to attach anything to Canvas. Again, Canvas sucks for code. It's just not good. So we'll put it all out here for you folks to look at. And then I'll export all the lecture recordings out to YouTube. So if you'd like to remain anonymous, just don't shout out your name. I think that'll work out pretty well. I've not had any issues with me live streaming, because everyone sees my face and not you folks. So goes pretty well. So yeah, I got some links. This is me. On Thursdays before class, I'm over in the engineering lab building. That's the new fancy $90 million building. Thanks for paying your tuition. Out there in the game lab, that is Dr. Bruce Maxim's lab for game design, all sorts of cool stuff that he does. And because this class is part of the game design track as the language elective, ideally before you take the game design courses so that you can do C# scripting and Unity and all sorts of fun stuff there, we get to use his lab. And then by the end of class, we'll write not a very interesting program, but a basic level game that will run on the Xbox Ones in the lab. The newer Xboxes have a little bit more of an obnoxious dev setup, and we didn't buy them because they were expensive and lots of reasons. So we'll run games on Xbox One. It's not as fancy and flashy as the new Xboxes, but it's still a fun experience. So your groups at the end of the semester, instead of a final exam, will present your final project. You'll play your game, show us your code. I used to do pizza, but Dr. Bruce said we can't have food in the lab, so we'll have to have food outside the lab after or something. So usually it's a lot of fun. We do a pizza party. and it works out pretty well instead of a final exam, because exams are stupid. I get paid a lot of money as a software engineer, and no one's ever told me I have to do it off the top of my head, because why? Like, that's just dumb. Hey, thanks for joining on Twitch. We got Sector Fox and Bernie. Thanks for coming in. Yeah, so I try and keep an eye on chat. Sometimes I forget, but I've got that there, so should be pretty good. So this was a copy paste out of the course catalog description. We do brief talk on DirectX. There's some libraries we can import. This is rather complex. So we use some libraries that sort of do the DirectX stuff for us, because doing it by hand is a big pain. Hey, Wolfmaster, thanks for donating your Twitch Prime subscription to the Scholarship Fund of the University of Michigan Dearborn College of Engineering and Computer Science. I got to get that right. So since I started on Twitch, Twitch has paid me about $350 or so, which I've donated to the Student Scholarship Fund. So thanks for watching the ad at the beginning of class, and then some guys like drops in all the time and donates $1 like every day, which is crazy. So the internet's an interesting place, and because it's a 3-hour night class, which is rough here. If you're on Twitch, there's channel points for fun. And one of the things you get is dad jokes. So I have a pack of dad jokes here. I do have 7 children. They are sick of my jokes, but you guys aren't yet. So what is Forrest Gump's password? Are you guys even old enough to have seen Forrest Gump? It's like a classic now, though, right? It was like my childhood. Oh, man, I'm old. His password is 1Forrest1. Even has numbers and letters. That one wasn't bad. Some of them are really bad in here, which I think is the goal. Like a good dad joke is supposed to be bad, so we'll keep those handy if we need them. All right. Some of the program learning goals. This just links to our website here related to the software engineering program. Specifically, if I did this link right here, things we do in the course. Some course objectives: design and implement simple games. That's what we're going to do. I like Atari clones because they're relatively simple, easy enough to handle. I'll show you a couple of games. I couldn't get them working in the last half an hour when I bothered trying, because they need a couple updates, because this was a couple years ago. So I'll show you a couple of the games groups did. Someone did like a 2D racer. Someone did like a brick breaker. Someone did a Tetris game. There's a bunch of fun, simple games you can do, which are just an intro to building out games. We'll do that. The algorithmic trade-offs when animating a game sprite. Thankfully, this isn't too bad for us with our libraries. We just say move, and it just paints itself. There's some complex stuff that happens behind the scenes that we just avoid usually, because it is a big pain in the butt to do. So I'm a big fan of libraries that do the work for us, and we're just going to take advantage of those. And then we can write medium-sized programs in C#. So like 1 and 3 happen with your game, which is cool. And then the rest is just fun stuff. The textbook here is not a traditional textbook. I found this book, someone recommended it years ago to me, and I've been following this guy since the 2nd edition. He does a really nice job here. It's pretty cheap, which is nice too. This is what we'll use for about half the class, for the fundamentals of C#. All the game stuff is extra material. There's enough tutorials online and other things we can find. It wasn't worth buying a $100 textbook for. So that's all just examples. So you can find it in the bookstore. You can find it online. It's like $30, so please don't pirate it, because he's a nice guy. He even has a Discord server that you can join, and he responds to questions in a Discord server, which is really cool. Again, GitHub, you need a free account. Please don't pay for anything. The GitHub account is free. You can use whatever handle you want, because when you turn something into Canvas, it has your name on it. So I don't care what your GitHub handle is. So go for it. Windows 10 or 11 PCs. If you don't have a Windows PC, you can use the ones in the game lab. They will do all the things you need them to do. For the first half of class or so, if you have a Mac, you can use Visual Studio for Mac, and it'll work okay. But once we get into the game portion here, we use the Universal Windows platform, which surprisingly doesn't run on Mac. Who knew? And then I prefer Visual Studio 2022. It's the newest, latest, and greatest version. Looks like 2019 is still in the lab, because I didn't think that I'd have to ask them in 2023 to install a new version. But it'll work just fine if you have 2019. Should be okay. The community edition that is free is perfectly fine. You need 2 workloads installed. So when you do Visual Studio, you probably did this a while ago, you actually get the Visual Studio installer, not Visual Studio itself. The Visual Studio installer says, hey, what workloads do you want? So you got to pick these little checkboxes here with the Visual Studio installer. You want the .NET desktop development here for our basic intro here. And then later on, we're going to use the Universal Windows platform when we get to the second half for games. And then if you're interested, I'll show you next week, but you don't need to unless you really want to. You can do the .NET multi-platform app UI development. This is .NET MAUI. It's not the best thing in the world. They're still working on it here, but it's kind of fun to say, hey, I can develop a C# app and it runs on Android and iOS devices, which is kind of cool. We can't run on iOS devices because issues, but you can run it if you have an Android phone. Just plug it in and you can launch it right on your phone, which is pretty cool. I'll show you. If you get a Mac environment and those sorts of things, you can do development and then run on iOS and all sorts of other things here, but I don't have a Mac. I don't particularly like Apple devices for lots of reasons, but again, that's my own issue, not yours. But we can do that as well, which is really fun. So these two for sure, the Universal Windows Platform and .NET Desktop Development we'll use. The MAUI's optional if you want. Again, we'll look at that next week, just kind of as a sidebar. So you'll need those ones installed. And that's about it for the tools that you need. Canvas, browsers, those other things I assume you already have. So what everyone seems to care about is how you get your score in the class. So we have quizzes just about every week. I'll have a quiz on Canvas. It's not timed. It's open book, open notes. It's literally to get you to read the book. Like, honestly, that's why I give quizzes, because if I don't have quizzes, people don't read the book. So yeah, please just go read the book and find the answers in there. It won't be too bad. They're like 10 questions. It should take like 10 minutes. So it's free points, essentially, if you go and read the book, because you can go find the answer in the book or the things that I said. So we'll have about one a week or so. Once we get into UWP, we'll probably stop the quizzes. So like through databases or so, we'll have a quiz every week. And we'll go from there. They'll be on Canvas. They'll be due like next week before the class starts. So you'll have most of the week to do it. I'll usually write them after lectures. So like everything's fresh in my head. I remember what I said, that sort of thing. Individual projects that we have through the semester, we should have about 4 or 5 individual projects that you folks will work on. And individuals may be the wrong word here, because like the last project I like to offer as a group project so that you can get to know your group. Because I don't assign groups. I let you folks pick your own groups, because assigning groups is just a big pain in the butt to do, and then people complain at me. So pick your own groups. I don't care. That's perfectly fine. It'll go well. Just one exam. We'll have one midterm exam. I'll give you a practice exam. It won't be too bad, I promise. I don't know if you've had me before for classes, but I don't think exams are a great way of measuring things, but they look at my syllabus kind of funny if I don't have an exam on it, to be honest. So we'll have a midterm. It won't be too bad. The group project makes up 40% of your overall score. It's the last month or so of class, and we'll have additional time to work on it as well. Like our last week of class, I don't have plans to say anything. I just want to show up and bounce around the groups and help you folks out. So generally goes pretty well for that. It feels like it's a lot, but going into the presentation, you'll know if it works or not. I'll give you a rubric. You get points for designing it a certain way. You get points for this. You get points for that. And you get a couple points for your partners evaluating you, saying you actually did your fair share of the work. So generally, everyone gets the same score in the group project, unless everyone in the group says you did absolutely nothing. Then you just get no points. And without the 40% of your score, you fail the class. So if you screw your team over, you fail the class. Right? Is that fair? Other than that, as long as you contributed, you basically get the same score. You might lose a couple points if you sucked at your contributions. You gave them crappy code, but you'll still get some points there. Right? Is that fair? So group evals should not be surprises. Right? If your partner sucks, tell them they suck. Say, you're not pulling your fair share, work harder. And if they can't do it, then they're screwed. That sort of thing, right? This is, at least you folks get to pick your partners. In the industry, you get to work with your team because someone else hired them. You generally don't hire your own team. So at least you have that flexibility. You get to form your team. So get to know each other. Hopefully you all know each other from other classes. Usually our software engineering group is a pretty cool cohort. You're not always exactly in the exact same classes, but you've probably seen each other before, I'd imagine. Let me go from there. So for the game lab, you can get badge access there, but you have to have completed the lab safety training. I'll post a link to that later. And then I need a copy of your certificate showing that you completed the lab safety course, which is silly because it's a computer lab, but it talks about chemicals because we have a single lab safety training course for all engineering. Because sure, this is what we do. The biggest thing is don't plug power strips into power strips. Like that's literally the only thing I learned in the training. I mean, well, the chemical stuff was, I don't care because we don't have chemicals in there. So in terms of what we care about in the computer lab, don't plug power strips into power strips and we'll be okay. All right. But you still have to pass the quiz and all that other stuff. So it's not too bad. But then you get badge access. So your U of M ID card will scan at the door, open the door for you. We don't let non-approved individuals in because it's an expensive lab, that sort of thing. But you'll get access, which is pretty cool. And if I recall correctly, I think the building's open 24/7. I don't remember if you get 24/7 access or not. I'll have to double check that. Yeah.
Only people with specific access can stay at the phone, otherwise they can.
So I have to request individual access. So I think you'll all be in the access list. I'll double check.
Not just access the room, but access to after hours.
So it's additional access beyond the room. Okay.
That only goes to researchers and.
Okay, so you'll probably have the standard access.
Yeah.
Do they actually like walk the halls and kick people out? Okay. Yeah. They say you need one every year. I don't know if that's academic year or calendar year. That's a good question.
Okay.
I'm sorry, these are not things I know. I got a reminder this like 2 days ago from my department chair. He's like, you need to renew your cert, but I didn't for fall, so that might have been why. Then we'll figure it out. Our tentative course plan here. Course intro today, talking about GitHub, talking about C# basics, .NET Core, essentially chapters 1 through 14. It goes really quick here because they're really short chapters. They're like, hey, here's a chapter on variables. Here's a chapter on arrays. Here's a chapter on this. Here's a chapter on that. I don't know if anyone, has anyone gotten the book yet or looked at the book yet?
My copy.
Saturday. Okay. Getting shipped, probably?
Getting shipped, yeah.
Okay, cool. So you looked at it. Bravo. You were the only one who raised their hand that you have a copy. I will give you some bonus points. Just shoot me an email. Okay? That is pretty cool. No one ever looks at the syllabus beforehand, which is, they like tell us we're supposed to put it out a week early because students want to see it, but no one ever reads it early. I don't know. Did you folks read it already? Okay. All right. Yeah, they didn't post the room number till like yesterday, which is okay. So some rooms they like will fit 50 people and some will fit 40. So if the class doesn't have enough people, they'll put me in a smaller room. It's a whole process. So I don't know. That's what it is. So we'll go through that this week. It's the intro. It goes pretty quick. We do some fun examples. We'll have our first individual project. It's not really much of a project. It's like, can you get Visual Studio working and do some basic stuff in it? Pretty easy. And then next week, we're out of the book because I want to talk about Windows Forms, Maui for cross-platform, XAML, our UI stuff that the book doesn't cover, because you'll see a lot of this in the real world. Depending on what you do when you end up, there's a lot of Windows Forms applications out there. It's a really nice tool for writing some quick UI stuff. So we'll talk all about that next week. And then just as if you want to design your program rightly, is that even a word? Nicely, correctly? I'm bad at words. You'll want to use an object-oriented approach, because what we'll do next week is we'll do the exact same project with a Windows form instead of at the console. So instead of typing stuff in at a black screen, I have buttons to click on. We'll talk all about that next week. So if your code is in a class with all the business logic, separate from your input and output, it's super easy to wire it up to buttons. If you write all of it in one big loop here in like a main method, it takes a lot of work to rewrite. So just fair warning. And we'll talk about that when we talk about the project as well. And project I use loosely. It's more like homework, but it's not very interesting. And then we'll get into, essentially there's object-oriented programming in C# is chapters 15 to 32. I'm expecting it to take about 3 weeks. It might take 2, it might take 3. We'll see how fast we go through it here. So it might be a little flexible as we go. And then the advanced topics 33 to 51 will take, again, maybe 2 weeks, maybe 2.5 weeks, maybe 3. We'll see. This like about 5 weeks for that part of the book. And we'll get through the rest of the book as we go. So the first half is a little bit of forms, and then the C# Player's Guide. This is our crash course in C#. Again, you all have a year of programming experience under your belt. The idea of this is what a loop is not worth spending a lot of time on. This is what a loop looks like in C#. Great, now we'll go use it. So we go pretty quick through it. Object-oriented programming, there's a lot of cool stuff we can do in C#. We'll hit some of those cool things and use some of those cool things in our projects that we work on. And then the advanced topics are really cool. There's a lot of fun stuff we can do, especially with threading in C#. It works out to be a lot of fun. And then we'll have our midterm week 8 before winter break is the goal. So we'll get that out of the way. So we get through all the basics of C#. So we have our foundation. Then we come back from winter break. We start with database programming, which is fantastic. We look at the entity framework. I'm a big fan of it here. It gives us a way to work with databases directly with code. So if you haven't taken a database class before, it's okay. Some of the concepts will be a little funny, but we're going to use code to handle data. If you've taken a database class before, great. You'll kind of understand what's happening behind the scenes. But again, you don't really necessarily need it here because we're going to do a code-driven approach, which is nice. And that way we can have data information that hangs around between when I run the program, when I stop the program, when I run the program, when I stop the program. We'll store it somewhere, because basically every application nowadays is backed by a database somewhere. We're getting data from something. There really aren't static applications out there. There are some, but most everything is backed with the database. So learning how to work with the database, at least this one approach, is pretty helpful. And after we finish up our database programming, we'll get into our Universal Windows Platform, specifically looking at XAML. So we'll talk about it a little bit next week. We'll get into it more on week 12, and this is when we start our final project. It'll be a XAML-based project using the Universal Windows Platform. Talk more about graphics week 13, talk more about game building, game design, this concepts of how I can structure my applications. Have time just for the group project, and then if I looked correctly, we should have our final project or final exam slot 6:30 p.m. to 9:30 p.m. on April 20th. I think that works out well because we do get the 1 week off for winter break. So that should be 16 weeks. So this is your future for Thursday nights. You folks all look very excited. You've not been drinking as much coffee as I have, obviously. All right. The academic integrity policy, I am very particular about this, and I hope you folks would be too. If you cheat, you fail immediately. It doesn't matter what you cheated on. If you cheated on a quiz, which is, it's open book, open notes. I don't like, okay. But cheat on homework, cheat on the project, whatever it is, you fail the class. Cheaters should not pass the class. Cheaters should not get college degrees, because when you go out to the industry and you get hired and you suck at your job because you cheated your way through school, your employer will say, oh, U of M Dearborn does a terrible job educating people. We're not going to hire those graduates anymore, which is bad for all of you who actually did the work and learned the stuff, right? So it's in your best interest for cheaters not to pass either. So if someone says, hey, I want to see your code, tell them to go get lost, right? Just get lost. Get out of here. Go do the work yourself. You're lazy. For real. Like, you paid money in the class. You should be doing the work so you're learning the stuff. It's not just busy work. Like, the only way to get better at writing code is to write code. You can read about it all you want, but you have to write the code to get better at it. It takes practice. I've been doing this for 18 years now or so. So some of the things I do will look very fast. I like keyboard shortcuts. I like all sorts of cool stuff in the tool that makes life easy for me. But I've been doing it a lot. Right? It's okay. You'll get there. It just takes time, practice, and doing it. So yes, just do the work. It's not too bad, I promise. So most what happens in coding is plagiarism. You turn in someone else's work and you put your name on it without citing your source. I know there's a website called Stack Overflow. I know it exists. People get paid a lot of money to find stuff on Stack Overflow and integrate it into their solutions as professional developers. That's perfectly fine. Cite your source. Just put a code comment in and say, hey, I found this on Stack Overflow. Ideally, the projects don't just have an entire solution on Stack Overflow. Now, Chegg, on the other hand, is a different example. Chegg lets you pay to cheat. They are an awful, terrible company. I hope they go out of business. They're getting sued. I'm so happy they're getting sued, although it's Pearson suing them, who I also hate. So I hope they both lose. I don't know. It's awful. But they are terrible. You may not cite sources from Chegg at all because they're literally paid to let people cheat. You post your homework there and people solve it for you. And they're like, oh, it's okay. If you have an exam, you can tell us your exam, and we won't let questions from your exam show up for 24 hours. After that, students can post questions for your exam as much as they want. We won't stop them. Like, if you can stop them for 24 hours, you can stop them always. And they're like, no, we're not going to do that because this is how they make their money. I hate Chegg. They are awful. And I can't get them to give me information unless I get a letter from the dean's office, which every time I pester the dean, I feel bad about because the dean has better things to do than to say, please, Chegg, please let Eric have this information. Because they will tell me who registered for the service and paid for it and posted the question. But it's a lot of paperwork to do, and that pisses me off because I hate paperwork. It's just a bunch of busy work. It upsets me, and I get irritated, and I complain at home, and then my wife complains that I'm complaining, and it's just a bad cycle. So we just don't do it, right? Anyway, if you do plagiarize, you get reported to the Academic Code of Conduct Committee. In 11 years of teaching, I have had to fail someone every semester. I do not understand it. It just boggles my mind why people still continue to cheat. Literally every semester. One semester is 8 students. 8. Like, it's not hard. Just do the work. Like, all right. Anyway, in those 11 years, I've had one case that the Academic Code of Conduct Committee said I shouldn't have failed the student. Once, and I'm still salty about it because they should have. And they're like, no, you didn't tell them they shouldn't have copy pasted. Like, it literally says it in my syllabus. But they're like, oh, but it was for a lab exercise. And you give examples for your labs. Like, I didn't for this one. Like, all right, anyway, I'm still mad about that. But you fail the class, you get reported to the dean's office. Our university has a 3-strike policy. You cheat 3 times and you are no longer welcome to be a student here. We also think cheaters shouldn't get degrees. So just don't. Okay? That being said, if you're not sure if it's plagiarism or not, ask me before you turn it in. Say, hey, Eric, I found this online. Can I use it? I'll say, sure, drop in a code comment. Here's your source. And we're good. Okay? It's not a hard policy. I promise. And then late projects and homework. I don't take things late because I will typically go over solutions in class when it's due. So all the projects will be due at 6 p.m. When class starts, usually the first thing I do is go over the last project whenever it was. So they're every other week mostly, but first two are like every week because they're small. I'll go over the solution in class because generally people say it's worthwhile to watch me solve it. Not that I'm anything amazing or fancy, but like I've been doing it for a while, so I take a different approach that you might take. So I'll show you, hey, this is how I solve the problem. We spend a little bit of time doing it, which is cool. So that's the plan. So don't turn in things late. That means, if things happen, let me know. We can look at alternatives if we have to. Just keep me in the loop if something terrible happens. But generally, you have lots of time to get things done. This is a 3-credit class, so that generally means you spend about 3 hours in person in class, or like working on lecture stuff, and then about 2 times that on outside work, like reading the book, doing your homework, practicing, studying, those sorts of things. So about 6 hours a week on top of the 3 hours a week in class. So 9 hours a week commitment for this class alone. So about what to expect. So plan for that, and then you should be in pretty good shape. All right, that should be the syllabus. Questions, thoughts, concerns? We did pretty good. Sorry to read to you. I know you folks know how to read. Sorry. Yeah. Cool. All right. So in terms of format, please interrupt me anytime. Anybody can go buy a book and read it. So like hopefully you've paid money to have someone explain things to you and answer questions. So shout at me anytime. I don't always see, like, you don't even need to raise your hand, just shout at me. I drink a lot of coffee, I'm pretty hyper. I did the end of semester surveys. I really like actually that they do them, even though surveys are kind of skewed and there's all sorts of research about them being terrible, but they work out okay for me because I'm a white guy. I'll just be honest. It is, which is terrible. But one semester, I had a comment that someone said, Eric is like a squirrel with an adrenaline shot. I'm weirdly proud and embarrassed of that at the same time. So just interrupt me anytime, because if it doesn't make sense to you, it doesn't make sense to someone else. Look how many people are in the room, right? You're not the only one with a question. It's okay. So just shout at me. You're helping other people. It's great. Man, I'm almost out of coffee again. All right. Cool. So we should talk about C#? Oh, yeah. It's just been one like quizzes on Canvas, or like a different format where I just come here on one single day and do the test. So yeah, I'll have it like the quizzes. So it'll just be open. So my plan is to open it on 2/23 and then have it due on 3/9. Okay. Ideally, you could sit and take it in class. Like if I wanted to watch people take a test, that's what it's designed for. I don't want to do that because that's obnoxious and not worth it. It's open book, open notes. Like go find stuff. So generally, they're about half quiz style questions, and then half long answer coding questions. Not big like projects, but like smaller in size and in scope. Like, hey, do this. Write some code that does this. Write a class that does this. Write an event handler based on the topics we've talked about. And I'll give you a sample from last midterm that I wrote for practice beforehand. Yep. Yeah. Don't memorize things. I don't know why we have people memorize things. I mean, you should be familiar with topics and know where to find more information. That's about what you need when it comes to programming. You need to know you can do something and then how to go find more information about how to do that thing. That's about it. That's what people get paid to do, right? No one should have it all in their head, or you can't have it all in your head. There's just too much when it comes to coding to keep it all in your head. I'm so sorry. I don't teach all the classes. So. From 150 where I was open book to 200 the next fall where I was doing writing down code with the pencils. Yeah, some folks still like trying to give paper exams, and I can't change their mind. But eventually they'll retire. C+ is passing. Yeah, that's all you need. Yeah, Apex, yeah, it's hard memorizing all the HTML, CSS stuff. Yeah, there's funny jokes about people post on Twitter. They're like, hey, I've been a developer for 20 years and I have to Google how to center something in CSS, which is fine. Like, there's no shame in that. And it's nice that we admit that as professional developers. Like, I'm a senior level developer and I have to Google stuff because why would I keep it in my head? It's okay. And we don't need to keep things in our head. We've got tools. We've got the internet. We know how to go do these things. So, or find these things, as I should say. Go find your answers. All right. So for Visual Studio and GitHub. So with GitHub, Git is the source control tool, the Git source control tool. written by our friend, or at least started by our friend Linus Torvald, the founder of Linux here. It's a version control or source control system. Its job is to keep track of source code and changes to source code, right? That's what it does. That's its job. The most widely used source control tool in the industry, by far. This is the best tool out there. GitHub is the hosting provider that provides a cloud-based central repository for people to synchronize with. They keep a copy out in the cloud for you, and then you synchronize with that copy in the cloud. Not a big deep dive Apex. We just kind of scratched the surface of GitHub. Excuse me. So a repository is nothing more than a folder that Git watches. So the course repository here is a public repository that anyone can go look at because it's easy, right? I'm a big fan of easy. When you have assignments and you are using Git, I will have a link for you. I'll show you probably after in the next little while or so. It will generate a private repository, which means you have access and I have access and our grader will have access. So thankfully, we have more than 45 students, so they let me hire a grader. So it means you get your grades faster, because if you look at my reviews, I'm terrible at grading things. That's the worst part of teaching is grading stuff, which I get you folks care about grades because they matter. Like, I just want to know if you can code. So the folder here, this public repository, anyone can go and make a copy of. Git is a distributed source control tool. So when you have a copy of a repository, you have a copy of a folder, you have everything, including the entire history, which is cool. So the big green code button is my favorite button here. You can say open with GitHub Desktop. The GitHub Desktop client is GitHub's tool for doing stuff with Git. It's not the only way. Visual Studio integrates with Git. Basically, all IDEs know how to work with Git because it's the most popular tool nowadays. I like the GitHub Desktop client because no matter what language I teach or what IDE I use, it's the same tool. So it's consistent for me, which is nice. And I can show everyone the same things, and it works the same way for everyone. It's very predictable. And it works well with the two-factor authentication. Because two-factor authentication is basically needed for everything nowadays because we just don't trust people. So I have a folder. Now that I've cloned the repository, I have a folder on my computer. I can use the Show in Explorer or Show in Finder if you're on a Mac, and it will say, hey, here's the folder. It likes to put these things in your Documents GitHub folder. Perfectly fine. If you want to put it somewhere else, it doesn't matter. GitHub will know where you put it. It's okay. You need to know where you put it, though, from when we start and create projects. So in here, you'll notice there's this .git folder. This is kind of grayed out. This is a hidden folder. Don't ever touch this folder. This is where all the Git magic happens. Just leave it alone. Most of the time, you won't even see it unless you have your options set in your view options to show hidden files and folders. If you have that set, then you'll see it there. Just leave it alone. You'll see a git ignore file. Sorry, this is my insulin pump yelling at me here. I'm a type 1 diabetic, so if my sugar is too high or too low, it's bad for me. Thankfully, this thing has software that keeps it pretty normal, but if it gets too low, I get really loopy. I've not yet passed out from low sugar, which is good, but I get real lightheaded and crazy. So I'll let you know, and I'll go get a pop or something, but it should be okay. So the git ignore folder, the file here says don't add these things to Git. If something shows up, I don't need a copy of it because essentially it's anything that can be generated and then anything private. So when we compile programs and get executables that run, I don't need to put the executable in source control because it's not the source code. I can just click the build button and generate a new one. So we don't need to track it in Git. So it has all sorts of fun things in here. This is the default for Visual Studio here. All sorts of things that don't go in. Anything in your bin folder, your object folder, release folders, debug folders, and all sorts of fun stuff here. This comes with GitHub. When you make a GitHub repository, you say, hey, give me the default file here. You're good to go. Just leave it alone. My repository has a license because the MIT license is nice and easy. So if anyone can use it, just cite your source. Pretty easy. Your private repositories don't need a license. They won't have one. So don't worry about it. And then a README file is how I got my pretty looking syllabus in a README file or Markdown file. So Markdown is a quick little format for putting things in stuff. Okay, so that's a folder. When you put something in the folder, the GitHub client will say, hey, there's something new here. Right? So if I go make a folder here, we'll call this week 1, and I put something in the folder, like just a text file here. We do a new text file, hello txt, and let's put something in here, hello world or something. Sure. The GitHub client says, hey, there's a new file here. So the changes tab of the GitHub client says there's new files. Green means new, red means deleted, yellow means changed. There's also plus, minus, and dots if you're colorblind, because apparently red and green are really tough to distinguish. So they also have icons because they're pretty smart. So it's new, and then because these are text files, you can see the contents of them. It says, hey, there's the contents say hello world. And not super interesting right now. What we do with Git is you create commits. A commit is a snapshot. Think of it as like making a copy of the folder at this point in time. It remembers the state and contents of every file in that folder. So I'll make a commit. You have to give it a commit summary. This is a required field here. This is a small box. Some like 100 characters. I've like a tweet. It's short here. So give it something. When you go out and work for organizations, they'll have standards around what you should put in your commits. I could care less because I'm not going to look at your commit messages here. I'm going to look at your code. But as programs evolve and maintain and we keep them around, you can look at this commit history and see cool stuff about it for big projects. But is that me? I can mute. All right, so we'll give it a summary here, like, I don't know, hello world. We'll commit. So now my local repository, my copy of the repository has the change, but now you see I've got a big blue push button. The central repository, the cloud, doesn't have it. I'm out of sync with the cloud now, so I need to go push to the origin. Now, you can use Git without a cloud solution. You can have a Git server locally and just on your network, whatever that serves as that central repository. I like the cloud because it's cloudy, or like it's out, I don't know, it's the internet, which is nice. So I think the school has one somewhere. I think there's one over at Ann Arbor if you wanted to use GitLab or something that you can sign up for free. But then you have to like connect to them and it's obnoxious. So we like GitHub because it's easy and you can use it from anywhere. So once I've pushed, now I've synchronized with the cloud, I can use the view on GitHub button. It'll go launch out the website. On the website, you can go and view and navigate these files and folders. So the week one folder is a link. I can click on it. It will show me what's in the folder. I'll see hello.txt. I can click on it and it will show me the contents of the file. For text-based files, you can see the contents. It lets you see them, which is really nice. So again, not very interesting. It just says hello world. But now if we go and change that again here, that adds more to it. Here's another line. 4 lines. Yay. Sure. My GitHub client says it's yellow. Something's changed here. Line 1 has changed. It's no longer this line 1. This is the new line 1. Technically, it's different because now there's a new line character there. Remember those new line characters that you don't see? They just mean we go down a line. So that's why it says it's changed. Doesn't look like it changed, but sure. And now, sure, 4 lines here. So here's more lines. We'll commit and push. And I'll go out to the website and hit refresh, and I'll see the new contents here. What's really cool is these line numbers are actually little links here. So I can take the URL here and say, hey, right at line 3, and I can copy this URL and send a message to Eric on Discord or email and say, hey, I'm having a problem at this line. And I can just see your code online, which is really nice. Yeah, AWS for government cloud. Oh, the government cloud's a whole other story, Apex. It's a like separate. Oh, it's interesting because we don't necessarily want to be on the public internet for some things. Yeah.
Can you highlight a range of lines?
Yeah. Yep. So as long as they're in a contiguous block. So you like shift click, here's like lines 3 to 4, or so on and so on. So you can see a bunch of stuff. So if you look at Microsoft, said which was the one? They've got a bunch of repositories out here. Here's their VS Code repository. So VS Code is a fantastic editor, which is open source, so you can see their source code. Go figure. So we could go look at some of their source code here and see some of this fun stuff here. I don't know what's an interesting one here. Node extensions. Sure. That was not very interesting. There's got to be one that like changed a bunch. Here's a bunch. So you can see what's in the file. See all the code for it. And then what you can do is you can use this blame button. This is one of my favorite things here. You can see when each line of code changed. So last year, these lines 1 through 12 were changed with this commit. The message here was add server folder. This is why the commit summaries are useful when people have like standards around what you should say for commit summaries. We don't really care that much because we're not going to maintain this code long term. Like you're going to work on the project and then forget about it. Right? So we don't care. But long term, these sorts of things matter. So if I have a bug in my program and someone says, hey, this thing isn't working, I can go to my code and say, okay, did this particular line that I'm getting an exception on change in the last couple days? And I can see who did it and see, oh, this one was changed by Daniel Imms. And then I can see like, hey, Daniel, do you remember any of this? Or like go ask them about it because I probably don't know. Maybe I could go figure it out. But usually like you just ask the last person who touched it because they're probably the most familiar with it. So it's a pretty easy way to debug things. And then if they broke it, they should fix it anyway. It's kind of their fault. So like blame, right? We're blaming who changed the code last, which is really fun. So you can go and see that sort of history here, which is really cool with GitHub repository. So Git is pretty cool at doing that. Right? So we can see all the changes. We can track files here. Once we have a copy of the repository in Visual Studio, when we make a new project, we're going to put it in that folder, because then GitHub or Git can track all the files from my project in that folder. So for C#, there's a bunch of different project templates you can get. There's a lot of them here. Like just looking at, hey, just want the C# ones just on Windows here. Like this is a big list of stuff. That's fine. We want the console app. So if you want to search, you can search for console. You'll see console app. Now there's two in here. There's console app and there's console app.NET framework. .NET framework is the older version here. You'll notice it's tagged for only Windows. So .NET is the runtime environment that runs Windows code. So C# and Visual Basic, if you've heard of Visual Basic, they both essentially compile down to the same code that runs on the .NET framework. So .NET is a managed runtime that manages all of this stuff for us. It's kind of like a mini virtual machine, essentially. So if you've heard of Java, Java runs on the Java virtual machine. Microsoft code, C# VB runs on the .NET framework or .NET library. So .NET framework is the older version targeted just for Windows. The newest, latest, and greatest stuff, .NET Core, that Microsoft has been working on is multi-platform. It runs on Linux, runs on Mac OS. You do a bunch of cool stuff with it here. So we're going to use the console app, not console app.NET framework. They both work for what we're doing, but again, console app, we'll just keep things straightforward here. It says, where do you want to put it? Don't put it in your source repos folder, right? Don't put it here because GitHub won't know about it. So I'm going to go browse and go find my documents GitHub folder, CIS 297, and I'm just going to put it right in here. Now, I probably want to name it something other than console app 1, because that's a terrible name for things, right? You want to use nice names, just like we name classes, we name attributes. You want to use nice names for things. So I'm just going to say week 1 here. Is that okay? Or I don't know, C# intro. How about that? Sure. You've got a checkbox for placing solution and project in the same directory. I don't usually do this because longer term, when you have larger projects, a solution is a collection of projects. For everything we're doing, we're basically one project, one solution, because we're doing small things, essentially. But as you get larger and larger and larger projects, you usually have more sub-projects in a single solution. We won't get there, but it's okay. So I generally don't check that just because we don't usually do that for large projects anyway. So, and it's just one extra folder. Doesn't really hurt anything. I'll say next. You get to pick what framework you want to use here. So .NET 6 is the current long-term support release, will be supported for a while. .NET 7 is the newest release, but only has a standard support term. For what we care, latest and greatest is best. That's easiest for us. We're not doing anything that needs to be supported for years and years, right? We don't care if it goes out of support in 6 months or a year from now, because we'll be done with the class, right? We've got 3 months or 4 months and we're done. So that's perfectly fine. And then this do not use top level statements. This is fun with the C# 10 and now we're on C# 11. They let you write programs without all of the extra stuff for small programs. So we'll take a look at what it looks like without those top level statements to start, and then we'll come back and use the top level statements to say, hey, here's my class, here's my main method, like you were used to doing with C++. At least you had the main method. So we'll just say that, and I'll say create. So I'll get my new .NET 7 C# program, and right away the GitHub client says, hey, there's new stuff. There's an SLN file, my solution file. There's a CS proj file, my C# project file, and there's a program.cs, my C# file. Inside of that, there's one line, or 2 lines really, a comment, and then console.writeLine, hello, comma, world. I've never seen the comma before. I think that's a little weird, but sure. So I see console.writeLine, hello world. You want to take a guess what this does? Yeah, prints hello world. You guys are good at this. Fantastic. So I hit run here. I think you're all familiar with Visual Studio because you did C++, right? Do you have any folks who transferred and never did C++ or never used Visual Studio? Okay, cool. So we get hello world, and then it says all this other stuff. You can make it automatically close, so you don't have to do read lines, or you could add read, all that other good stuff, sure. Why not? So it's running this executable here. So if I go look at my bin debug folder, there's a little executable I can go run if I want, and all this fun stuff. But we get hello world. It works. Notice we don't need any of the other stuff. We don't have a main method. We don't need this to be in a class here. It just lets me write code and start writing right away. It assumes all of those things for me for basic program. It looks a lot more like a scripting language now, if you've done any sort of scripting like in Python or other languages, right? Because we don't have the rest of the stuff around. It's implied. So there's a little link here, like, oh, hey, do you want to know what happens here? It's generated for you. It just assumes these things. So if we want to make another project and see all those fun things, we make our console application. This is week 1. This is with top level. Go next, and I'm going to check my box to say don't use the top level statement. So don't imply them, which is weird. It's almost like a double negative, because you'd think by checking the box you wouldn't have them, but by checking the box you do have them, which I don't understand. English is hard sometimes. Let's save that. And now here we get all the other stuff. So this is what it would usually look like here. Here's the namespace, which is just the name of your project essentially. And you get a class called program, usually matches the name of the file. It doesn't have to, but conventions are nice. And you get static void main string args, like you're probably familiar with here, and then console write line. So this gives me the exact same thing as I got with the other version. Right? We just get to avoid all the other stuff. So it's going to look very similar to C++. We like curly braces. They define scope for us. We have classes. We have a main method. And we can write other functions. And we'll talk about all that in a little bit as we go. So either one's perfectly fine here. So I'm going to go back and open my other one here. It's my recent. I have, oh my goodness, going crazy. I'll just close it. Come on. Well, can I just open? All right. Usually get like a recent list. That's weird. We'll do with this one. I prefer this syntax. This is just a little cleaner, a little easier to see. All right. So fun things in C#, right? A lot of it is very similar. We have ints, we have floats, we have doubles, we have strings. Now, string is technically a class, but the preferred syntax here is lowercase s for weird reasons that I still don't really understand why, but sure. So I can say, hey, my string name is Eric. Great, now I have a name for Eric. And now, right away, it's telling me, hey, you used this variable, or you assigned it, but you never used it, dummy. Tries to be very helpful. Some people don't like these lines. They drive me nuts, usually. But we'll fix them quickly. So as long as they're not red lines, right? That's the usual. Red lines are the bad ones. The other ones are just helpful hints. So if you don't like typing console.writeLine here, you can do CW and tab twice, and you get console write line. Again, I'm going to use all sorts of shortcuts. I promise I don't actually type that fast. I'm just a fan of type ahead. So I'm going to use a string here, and then we get string interpolation. It's a fancy term here for a string that has variables embedded inside of it. So with a $sign, because it's what they picked here, we can give it a string and start giving some variables. I can say, hi there. To get a variable interpolated, you use these curly braces, because who else ever prints a curly brace in your actual string outputs? Well, they had to pick something. And I can say the variable name here, it will get taken out and embedded in this string. This is by far the most common way of using strings nowadays, because it is fast and you can see the name of the variable right in here, rather than something like, I would say, hi there, and then plus name, right, is one option. This sort of having to concatenate everything together, smoosh our strings together, is obnoxious. And then you have to end quotes, and you have to start quotes, and if you have more than one variable, all sorts of obnoxious things here. Right? This is much easier for us. We're all about easy. C# has all sorts of, we'll call it syntactical sugar, things that just make life easier for developers, because it's written by developers for developers. There's a great clip here. I think I can play this one. Oh, I can't type. Where's the video here? I think I can do this without getting copyright strike because it's short.
Developers.
Yep, he's a. We don't always like Steve Ballmer. He wasn't the greatest guy, but that video there was a classic. And that's Windows strategy essentially is make life easy for developers, so people write apps for Windows, and people will buy Windows because they want to use the apps that run on Windows. So that's worked out to be a pretty good strategy, right? I think it worked out pretty well for Microsoft. So C# is full of these fun little shortcuts that just make life easy for us. And that's what a lot of the differences we're going to see from C++ to C# are the sugar. Conceptually, it does the same things. It's just we have a lot of shortcuts to do these things for us. There's a huge library of cool stuff we can use and take advantage of. We don't have to reinvent the wheel for, and we can just go. Wow. look, it's giving me more suggestions. That is fun, but sometimes obnoxious. So I don't know. Sometimes suggestions are nice. Hey Ryan, thanks for joining on Twitch. Good to see you. So you'll have to remind me because I like to talk a lot. That about every hour or so, so like around 7 o'clock and around 8 o'clock or so, we should take a break to go out, get some more coffee, use the bathroom, do those sorts of things. So typically we'll take about 10 minutes at 7 o'clock and 10 minutes at 8 o'clock, and that works out pretty well because I mean you folks get tired of sitting there listening for a while, right? So you got to get up and stretch, play a quick round of Magic or something, and then we'll come back to it. So in just a minute or so, we'll take a break and we can go from there. So if you need one earlier, you're welcome to just get up and walk out. Right? I feel terrible saying it, but honestly, I don't care if you're here. Right? Like you can watch the recording if you want. If you want to be here to ask questions, that's fantastic. I like seeing you. I'm a very people-y kind of person. I like people. I'm still an introvert, so it's draining. But like I enjoy being with people for some amount of time, and then I have to go do my own thing. Yeah. Yeah. So Twitch is really nice because I get a one-click export to YouTube rather than when I had a Zoom thing, I had to like re-encode the video and I had to upload it and I had to make it a private upload because it had people's names on it and it was just really obnoxious. And one time, so I used it for like one semester and like one time one person said one thing. Other than that, people would use chat. I'm like, well, if people are just going to use chat anyway, let's go back to Twitch because this is easier. We're not a discussion-based class, so it's not like we need to go into breakout rooms and you can talk amongst yourselves and that sort of stuff. It doesn't work like that. I'm giving a bunch of examples. It's an information dump, and then you go and try some stuff. So I think the format works pretty well for this sort of thing. And it's fun. I was a giant nerd and watched stuff on Twitch beforehand. Got started years and years and years ago when Day 9 would cast StarCraft stuff on Twitch. It was a lot of fun. So I don't know. I think it was 2018, 2019. I started streaming stuff on Twitch because I was like, hey, winters suck. And sometimes getting here in the middle of a snowstorm is awful. So I have to be here for an afternoon class. So as long as like roads get plowed by noon, I can make it here to campus. I'll be here. But if you folks are coming from far away and there's snow, don't come. You don't have to get into a car accident, right? Just stay safe. If you want to come, great, perfectly fine. But if you want to just be remote, go for it. Just be remote. It's okay. Wolfmaster, you want a knock knock joke? Okay, so I have dad jokes and I also have a pack of knock knock jokes. We'll do this and then we'll take a break. All right. I don't think that's a good one at all. I'll skip that one. Okay, knock knock.
Who's there?
Hey. Hey who? It's off to work we go. Oh yeah. These are particularly bad ones. So all right, so why don't we take a minute? We'll take a quick break. I'm going to commit this to GitHub so you can see. Hey, there's a bunch of stuff here, right? And we can see these change as we go. We'll come back in about 10 minutes or so, and we'll pick it up from there. Put some music down for you here. Alrighty. So I didn't trust that coffee machine. I don't know if that was actually any good or not, but I got a Coke instead, so I'll stick to wired. Getting back into basics C# stuff. We have nothing super novel or interesting. This should be a quick rehash of some of the stuff you did before, but how we do it in C# and some of the fun things here. If you want to get input, right, we have this console class. We're probably going to use the console class for writing and reading, right? That's a pretty good guess. So if I want to have a string for your name, we'll say it equals console.readline. Yeah, tab, sure. That's fine. And then we can write something. Now, we do get this lovely warning here that technically console readline is telling us returns a type of string question mark. The question mark means this object is nullable. It's possible I do something dumb at the console and I get back a null result. I don't get an actual string. It's a little bit obnoxious. Most of the time we don't care too much about it. But that's what that warning is for. So you'll see it. It's okay. We're just going to ignore this one. Sorry, we feel that one. Yeah. So console is a class in the C# library. So this comes from system.console. So the system library, system namespace, has all sorts of things C# can do. Console is a class that lets us interact with the console. We're reading and writing stuff to the console. Yeah. So instead of C in, C out, we just use console. Does that make sense? Yeah. So console dot, you get all sorts of cool things you can do with it here. Bunch of things. Not tons of things, but it deals with the console for input and output. So you can do fun things like change the color if you want. It's set. Something about color. Where's it? Console.color. Yeah, we can set the foreground color or the background color. Sure, we'll set it to red. And then we'll write something here. We'll say, hi there. Add another $sign, and we can say your name. So now when we run this, it's going to sit and wait for some input here. Now, again, it's not the most interesting program because we didn't like output, please enter your name. We just said console readline. So it's waiting for me to enter something. I don't know what I'm supposed to enter. So again, we did a bad thing here, but it works okay. So if I enter, what do we want to put in here? We'll say we'll do Jeb for my son here. We get hi there, Jeb. Now it's in red because we changed the color to red. So anything console related comes from this console class here.
The question mark.
Yeah.
Can that still be used as like a shorthand ternary?
Can it be what?
Like a shorthand ternary or something, like in C++.
Yes.
Okay.
Yeah. So yeah, you can use the ternary expressions with the question mark, but when it's attached to types, it means it's a nullable type. So a string question mark means it's a nullable string that might be null here, rather than shouldn't be null. We'll get to it a little later. It gets a little funky using this nullable type, and then you can do all sorts of fun things where things can't be nullable, and all sorts of fun stuff to keep you from shooting yourself in the foot with nulls, because null pointer exceptions are like the bane of our existence as programmers. We just shouldn't give back null, and we keep giving back null in places we shouldn't give null, and it hurts everyone. So most of the time we'll ignore it for now until we figure out what to do with it later. So some basic console stuff, reading and writing. Now, none of this is super interesting here. It's just a bunch of code. So if we want to go write some functions, we can go write some functions. Now, C# is pretty nice that it doesn't really care where you put your functions. Some function. And usually we'll do not camel casing, but whatever they start with the capital letter and then camel casing is. I don't remember the word off the top of my head here. So we have some function here that does something. We don't really care what. So we'll just write line some function. And then in my code, I can just call some function. Usually, you're probably familiar with, you'd have to have this defined above, right? But C# is compiled, and the compiler knows to like read the entire file first, not try from top bottom, or top and read its way down and be like, I don't know what some function is because we defined it lower down. It's okay. Need some input here, and then we get still in red. Sure, that's fine. We have our some function. We were able to call it. So with this syntax here, we can put them anywhere. It gets a little funky without all of the other places. Now what's nice is I don't have to say this is static. I don't have to put all sorts of other declarations around it here. Where with my other version, right, we need static methods to call from static methods, those sorts of things. If you have instances of classes, then you call the instance methods. You're thinking back to 200 and all your object-oriented stuff, works the same way. So it's a little bit funny without the rest of the curly braces around the class definition, but if we just want to do something, just a quick run some code here, this works out pretty well. We don't need all the other bells and whistles here. All right, if we wanted to go do it in our other version, we can go open up our with top level. And here's my main method. So if I wanted another method, it'd be outside these curly braces, right? Because the curly braces define the scope of main. So outside of main, I'd want void some function. And we'd countable right line some function, right? Now in here, if I want to call some function, notice I can't call some function. It's upset with me because it says, hey, an object reference is required for the non-static field method or property program some function. We have to include that, yes, this is static. It exists once at the class level. We're defining it once. I don't need an instance of program to call it here. Now I can call some function. So I have to do a little bit extra work here if I have all my top level stuff here, but it works the same, and I'll get my some function was called and all that other stuff works here. So with the top level implied, it assumes when we write functions, they're static because we don't make instances of classes. We're not defining classes because we're just, here's a little static main method. Just assume it's all here. So a little bit of magic behind the scenes there. You just got to be a little cautious of. So, and whichever one you're more familiar with or prefer to use, is perfectly fine. I don't really care for our first program which version you use. It'll work the same way. We're just going to write some functions. It'll work out well. If you want to use classes so that you can reuse it for the second project where we use it in a user interface, you'll probably want this version. Right? So we can define classes and do those sorts of things. But you don't have to. Right? It's totally up to you. All right, so there's our functions here. Let me go, I'm going to grab my book here because I don't remember the order of all of his chapters here. So we're in the basics. Okay. That's width, really? That's weird. Okay, sure. Visual Studio, C#. I'm not particularly fond of comments. I apologize. In general, we tend to have this aversion to comments in the industry because you can change the code and not change the comment. So comments get stale really fast. And it's a bit of a pipe dream, but we still all kind of believe in it that code should be self-documenting. I should name my classes well. I should name my functions well. I should name my variables really well so that you can just read the code and know what it does without a comment. I'll admit that doesn't always work, but that's the goal. So the default should be no comments. But if something's really weird or crazy or funky or we have to do some special handling, we should add some comments to explain it. But that should be the exception, not the rule. I don't know what other people told you, and that's okay. Whoever gives you a grade or signs your paycheck, if they say write comments, you write comments. You smile and nod. Say, okay, this is fine. I could care less about comments. I don't use them. If you want me to add some, just shout at me. I'm happy to add them in because what makes sense to me doesn't always make sense to other people because you're not in my head, right? So I can add in comments for you. Like, hey, we needed to add static or something like that. Just shout at me. I'm happy to add them, but in general, I shy away from them because instead of adding a comment, we should make the code more clear. Is generally what we should try and do. So, and because we get autocomplete and we don't have to type everything myself, it's perfectly fine to have some method does this special thing, other thing. I don't know, like make a really long method name. No one really cares how long it is. I mean, as long as you can see it on a screen. Now I'm zoomed in a little bit here, so if you're more than like 140 characters or so, you've probably gone too far. But you can use a really long method name that explains what it does, rather than write a short method name with a long comment that says, this method is for adding a variable up to, just name your method better. Again, it's a bit of a pipe dream, but that's generally the goal here. Right? Use good method names that self-describe what happens here. So we generally skip over comments. They work the same way. They're 2 slashes or /* for block comments, those sorts of things. We got some variables, types. Again, we have ints, we have floats, we have doubles, we have strings, we have chars. The general primitive types you're probably familiar with all work in C# as well. What's fun though is you also get automatic variables. I don't know if you saw auto or not in C# or C++. Does anyone work with auto variables where the compiler knows what type it is? So I can say, hey, here's a name, is Eric. I don't need to tell C# that it's a string because I'm giving it a string. So the compiler says, oh, it's some sort of variable type. I'll figure out what it is based on what you give it. So you'll see a lot of this var here. And if I just hover over it, it says, hey, it's a string, which is nice. Now, you didn't really save a lot of typing. I'm not, some people really love var and they var everything. Sure, I don't really care one way or the other because we didn't really save a lot of typing. But when you get to some crazy types and you have lots of pieces happening here, or we're using certain data structures and you've got your diamond operators, you can save some typing with var. That's fine. We'll get to that in a little bit. But sure, if you want to use it, go for it. If you don't want to use it, it's okay. Yeah.
What would var be useful when you map a function to variable?
I mean, you know what the type is based on what the function returns. So if it returns a string, it'll be a type string. Right, so if this one returns a string here, how about an int? I don't know, a double. We'll do a double. We haven't done doubles yet. We can like return 7.7. So I can have var number is some function that does some other special thing. And now my var is a type double here. And notice it's actually system.D double, not the lowercase double. Usually we'd say double other number, 4.2 or something. C# does this boxing, auto boxing and unboxing for us. So all these primitive types map to the classes. All the classes map back to the primitive types. Sort of behind the scenes works for us nicely because you can get all sorts of fun stuff there. So double dot, you can do all sorts of fun things with double here. So we don't actually use parse all that often. You can. The try parse is nice, but it's usually the convert. It's pretty easy. You can say convert dot to whatever, and we'll convert things. I see more people use convert. So try parse is nice if you want to not crash. But we can deal with input and output another time. Not too big of a deal. So yeah, if I want to convert things, so if we say, hey, enter a number, so we'll get a var. How about input is a console.readline. We should tell them what. Tell them what to enter. We'll say, please enter a number. We'll get their input here. Now I need that as a numeric value. So input as numeric or something. Sure. So convert dot to double given the input. Yes, input. There we go. Look at that. Sometimes these type of heads are nice. So we can convert it this way. Right, pretty nice. This way I can deal with decimal places. If it doesn't have a decimal place, we don't care. It'll still be a double. Hector, my friend, thank you so much for donating those bits to the Student Scholarship Fund at the University of Michigan Dearborn College of Engineering and Computer Science. Sometimes I trip over that, but I've had a lot of practice. All right, so we can get our input as numeric, and then we can do basic arithmetic, right, if we want. So we can say, I don't know what, our number, how about add in here, we'll do an interpolated string. So we'll say other number times input as numeric. My goodness, where's my key? Input, come on, type ahead. Sometimes it hates me. There we go. Input as numeric equals, and then we can actually do the arithmetic in the interpolation here if you want to get fancy. And we'll see if our math is any good here. All right, enter a number.
23.
I heard 10 first. So 10 times 4.2 is 42. It did some math. Look at that. The computer can do math. Yay. All right. Works like you'd expect it to. Right? Does the arithmetic. If you take integers and divide by integers, what kind of result are you going to get? An integer, yeah. So, my goodness. Fingers are not working right now. All right, so if we say, I don't know, how about, I've had a lot. It's been a long day. My daughter was up at like 4 because she had a bad dream, and then I couldn't get back to bed for a while, and that's fine. It's fine. So 5 divided by 2 is equal to 5 divided by 2. We can actually just plug it in here and see what we get. Right? We get integer division. So 5 divided by 2 as an integer is going to be 2. You lose the decimal place, right? If you take anything, if either part of this is divided by a double here, you'll get a double result, right? So 2.0 is a double. You'll get a double result or a floating point result here. It works out pretty well. So we like these. 10 again, right? 5 divided by 2 integer divisions, 2. 5 divided by 2.0 is 2.5. How about some other fun things here, like divided by 0? Now this one right away redlines us here. Says division by constant 0. It knows we did a bad thing here. But if we did our, how about input as numeric here? We don't know what we gave us here. What do you think we're going to get? We'll come back to this one in a second. If we give it 0. Can we try that? Because 0 is a number, right? It should parse it here. So 4.2 times 0 is 0. 5 divided by 0 is infinity. This is true, but weird. It's not really a number. I'm pretty sure. It didn't throw an exception because infinity is a valid double. Go figure. Weird. It's not useful. Doesn't do anything for us. So you got to be careful and don't do things by 0 outside of it because it won't crash. But if you convert it as an integer here, so we do this as to int. Now there's a bunch of different ints, which is obnoxious. So int 16 is a short. I think you probably heard about shorts before. PJ, thanks so much for subscribing with your Prime sub. Int 32 is our regular integer. Int 64 is our long. Are these types sound familiar? Okay, so there's different number of bits that we use for each of these. You can also have unsigned versions of these, which means they won't be negative, so you get double the space in the positive range. I don't really care. Memory is cheap. We're not doing anything by the million scale, so use doubles because they're easy. Or use big integers. It doesn't really matter for our purposes, but 2 int 32 when we're converting. Or if you want the other conversion here, it's integer %. Nope, just integer. Integer dot. No, dot %. Oh, sure, int dot parse. Sure, why not? So we could also use int dot parse our input here if we wanted. And now it's upset. Yeah, we don't need to declare it again. We can just, sure, why not? Possible null reference. You might be doing a bad thing. That's fine. So if we try and divide by an integer value of, say, 0, now we get a crash here. Because as an integer, we can't store infinity. As a double, you can. I didn't make the rules. We just follow them. So just kind of depends on what you're doing here. That's perfectly fine. So again, it can tell when you're compiling if it sees a constant 0, but because it was input-based, it had no idea. Right? The compiler is only so smart. So do be careful here. This will crash with zeros, but that's okay. It's what we'd expect. So that's stored with variables, the type system. There's a couple other things. So we have a link right to that. Take a look at chapter 6 real quick. Yeah, the other types. Strings, again, we get booleans, you get vars, convert for converting things. That's pretty much our basic types of primitive types that store values, right? This idea that these are the basic types here. They're not really classes. String is technically a class, but we just kind of wrap it. Yeah.
Will we be able to convert things like from, for example, into character?
Yes. I don't know if the convert library does that though. So if we say convert to char, you can give it, yeah, so there's 17 different overloads we can give convert to char. Looks like you can give it all sorts of different types here. So you can give it booleans, you can give it bytes, you can give it chars. Why would you convert one char to another? You can give it a date time to convert to a character, a decimal, a double, a float, an int. Sure, why not? So these the IntelliSense here is amazing for finding this stuff out. Or you can just go Google the C# stuff, the library. There's the documentation online as well. So yeah, it looks like we could.
That's the stuff that really blew my mind.
Yeah, dealing with types can be really obnoxious, but it's nice to know your types. Other languages are typeless and they just don't really care, which is a bit of a change if you're used to being fully typed or strongly typed. So it's just kind of depends what you're used to, for sure. All right, so we've got dealing with those. Let's see, what else do we have here? The math library. Please tell me you all know how order of operations works. This makes me really sad every time we talk about this in an intro to programming class. And then you get that nonsense of like, hey, what's my math problem? Only 60% of people, you guys aren't boomers, so you don't use Facebook. But like people share these nonsense things. They're like, only 60% of people get this question right. What is, and they do, 5.
I'm in the middle.
you know what, 5 divided by 2 times 3 or something. If you write it like this, I blame your math teachers for being ambiguous. Math teachers are lazy, let's be honest, because 2 parentheses 3 is implied multiplication, right? Just because they're touching doesn't mean they have precedence. Order of operations still goes left to right. So you do 5 divided by 2 first, then you multiply by 3. Everyone should be shaking their head. We know how math works. Okay, good. Thank you. This stuff is just nonsense. So probably like 6 is probably better, but whatever. So order of operations applies, same that it does in other programming languages. Yeah, so 6 divided by 2, then times 3. So just because the 2 touches the 3 doesn't mean we do it first. Right? It's just implied multiplication. So it's the same as having this. So we do 6 divided by 2 first. I once had someone argue with me, and I don't understand how they got to college, that because when you say PEMDAS, parentheses, exponents, multiplication, division, you do multiplication first. And I about screamed. Like, no. Do you do addition first in your problems because you say addition and subtraction? No. Like, I don't understand, but it's okay.
You 6 times 3 and then divide by 2.
That works out to be the same thing, right? Because is that the transitive property or something? Community math is hard. I don't know. Yes, yeah. So just use parentheses. So order of operations is great. We like those sorts of things. We get our same combined assignment operators. These are fantastic. We love these. You get the prefix and postfix operators for plus plus. Someone once told me that plus plus A is faster than A plus plus, and I don't care. I'll be honest. Like, go for it. Sure. No one's going to notice. Like, okay, you feel better than me because you're smarter. Go for it. I don't care. I don't have to be the smartest person in the room. It's okay. Eventually, you can get not a number result, NaN, which is fun. Other than there's actually negative infinity as well as positive infinity. You can get max values, which are cool. You can cast without converts if you want to cast things explicitly. And then math and math F is math and then math with floating points, essentially. Lets us do things here. All sorts of math functions, math.pi, if you want the definition of pi to however many digits fit in a double, go for it. So all sorts of fun things in there in the math library. I like how this guy writes his book because this is the speed run. Right? We're just speed running through this because you have programmed before. If you've never programmed before, you don't speed run these chapters, but you folks don't need the long version, right? All right. Console 2.0, other fun things we can do in console, changing colors, changing the title. Beep is one of my favorites here. So you can do console beep, and we'll say, oh my goodness, thank you. Console.beep. So what frequency and what duration here? And it should beep for us. Enter a number, beep. So you can make it beep. If you just Google console beep, the example here on Microsoft gives you, that's not the one I wanted. Where's the other one? This one here. See if we can make this one work here.
Will you miss 1,000 minutes?
There's 3 milliseconds. Yep. All right, one more time. Yeah, Harry had a little lamb, so that's a fun example there, but I'll just undo that. So console beep is just silly. I don't know if it actually be useful for anything other than annoying people. But sure, you can put in beeps if you want. Why not? Some of the frequencies my computer didn't output very well, or like at all. I don't know if it. I don't know anything about frequencies.
You can't go under 100. You can't go under 1,000.
Like it just didn't play them.
Yeah,
unless
speakers can't make that sound.
Okay, so I know nothing about actual music, so sure, but yeah, there's like different tones, and they have like these all defined here. Of these ones we can use, and they're enum here. Go for it. G below C, the regular G above C, I guess. So I don't know. You can do all sorts of fun things. A whole note is 1600 milliseconds, 1.6 seconds. Sure. Okay. But yeah, fun stuff here with console beep. That's some fun things we can do. Your escaped characters, / new line, / tab, / quote. I think those are all the same from C#. The @ sign is really cool. It essentially is a raw string or literal string. It's going to ignore everything in it, and just nothing is escaped. So you can just put in literal backslashes if you want here, and they are treated as / characters rather than you have to / to escape the escape character, which is kind of annoying. So we get that, and then our $, the string interpolation we've been using. So I can put in the curly braces to do those sorts of things here, which is fun. All right, that's console. If, else if sorts of things. Hopefully nothing new here. The ampersand, or pipe operators here, right, for and or. But recently with the newer C#, I think we should be able to do this. We can say, where's our, I'll do something here. How about this one? We can say if my input as numeric is greater than 0 and input not where and operator supposed to be supported. What is it giving me? And that's not useful. No. Okay. Oh, okay. I guess it's not doing it. So we'll just use the ampersands. I thought at some point they were going to convert over to the numeric is less than 100 or so. Input as numeric. Okay. For ands, pipes for ors, just be careful with them. Same thing as before. All right. They do make a difference depending on what you're doing here. You can, I don't know. Our number is 0 to 100. Sure, why not? And then else, console right line, too high or too low. I don't know. Sure. And then later we'll put this in a loop and we'll make sure they're entering a number between the right values. But nothing surprising here, right? Straightforward. Okay, cool. Yeah, those ones are pretty boring here. Someone had mentioned the ternary expression here. So we can say, how about our result is equal to, now I can say my input as numeric is greater than 100, question mark, too high, otherwise we'll say okay. I don't know, right? This funny expression is a way to do an if-else in a single line. People seem to be obsessed with writing things in one line of code when they could do it in 6, because why use 6? I'm rather particular about the curly braces. You technically don't need them for a single line. Just always use them. It's really a good practice to just use the curly braces. You probably don't remember, but wow, dozen years ago now. It's really, I'm old. Safari had a bug where SSL was breakable and you could get past someone's encryption because one of the Apple developers didn't use curly braces in one of their switch statements. Yeah, curly braces are your friend. We'll explicitly define the scope of if-else things because we like them. But if you want to do it in a single line to skip your curly braces, use the ternary expression. Sure, we can just, if it's going to assign something, great. It would get the question mark version first, the colon version second, if it's false. I think these are weird, and I don't really like them because I always forget which one I'm supposed to do first, question mark or colon, or which one is true and which one is false, and it just hurts my head. But some people love them. Yeah.
Eventually, if you React, which is in JavaScript language, there are some instances where I have to use ternary when I thought.
And it wouldn't work.
Yeah, it's when you write Java in HTML.
I've never seen it not be replaceable, but that's interesting. It's cool. Apex, thanks for subscribing with Prime. I appreciate you donating to the Student Scholarship Fund of the University of Michigan Dearborn College of Engineering and Computer Science.
It's why simple and like some people use too many lambda.
Yeah, we'll get into those, which are a lot of fun. Yeah, that's one of the other fun syntactical sugar things we get. So your not operator, Booleans. So the only thing I'll really complain about for people that a lot of times in their functions, we write some function here. We'll say static void. How about get bigger number? Given an int number 1 and an int number 2. They'll say if number 1 is greater than number 2, or no, let me say this should be a Boolean here. So if is 1 bigger than 2. Let's do this. So if number 1 is greater than number 2, return true, else return false. Perfectly fine, legitimate code here. But if you're checking if something's true and then returning true, just replace all that with return number 1 is greater than number 2. Right? That's the exact same thing. So I'll complain about this, where we should do it in one line rather than 6, because it's the exact same thing. And a lot of people do the other format, which is fine. Doesn't hurt anything here, but it's just more work than you need to do. So, right. And if you're comparing something's true or false, to return a true or false, just return the thing you compared. That's all. That's not a very interesting one, though. But yeah, so ands and ors are really, they can be awkward. Just be careful. Make sure you're doing the right thing. Test it out. Plan it out. Make sure we're comparing the right thing here. Switches are fun. I don't actually like switches most of the time, but that's just, I just don't prefer them here. The syntax, right, with breaks is obnoxious. I don't like breaks. The fun thing we get to do with the new version of switches, though, is we can use these switch expressions here. So I can say, 1, do this thing. This is what I'm going to get back from my switch. So this is a little bit more concise. I think I like this sort of syntax a little bit better here, which is nice. So you can do that, right, based on what their value was here. Right? We're going to switch on choice. So we have a little menu here, like we can, get their response here. So we'll have a another method for it here. So a static string get choice given an int choice. Sure. There we go. So we have a string for response. We're going to assign it the value of switching on choice. Now that instead of switch choice, you say choice switch. I don't know why, but sure. And then when we're done, we're going to return response. Semicolon? Sure, that's weird. The underscore is the default case. So if it doesn't match. So you'll see a lot of pattern matching happening in C#. If you look at other C# code that people write, where they do this sort of thing, where if it's this matches this pattern, you get this result. If it matches this pattern, you get this result, that sort of thing. So this is relatively common with switches now. And you get kind of a concise syntax, which is nice, but it's comma separated, not semicolon separated, because it's technically all one statement. It's a little funny syntax-wise. So just, if you want to use it, go look it up. It's no big deal. We can do those sorts of things here. So those are kind of fun. About the only reason I would use a switch. I'm sorry?
You know, there's a time difference between them.
What do you mean a time difference?
So like, wouldn't they have to check the entire statement to see it?
Runtime.
No, so as soon as it finds one, that's it. So there are no, like with a switch, sometimes you could have multiple catches, and with a single break, like halfway through, it doesn't do that. This is a 1-for-1 match. So as soon as it finds one, it's done. So if it matches 1, you get 1 and you're done. It doesn't check anything else.
Okay.
Yep. Yeah, so you can switch on things. Sure, those are fine. Loops, while loops, do while loops. I hate do loops simply because this semicolon here. I hate this semicolon here because we don't put semicolons in while loops, but you put them in do loops after the while. Drives me nuts. The for loop is really nice in that these items here are pretty flexible. We're going to use a lot of for loops for doing things, right? They're pretty common here. And the other really nice loop is our for each loop. Where's our for each loop? Let me find it in here. Yeah, nested loops aren't fun. That's fine. Where's my for each? Did I miss it? Maybe it's not in this chapter. I'm thinking of something else. All right, okay, it's not till we get to arrays. That's why. So these basic loops should be exactly the same that you've seen in C++. Nothing special here. Break to stop the loop, continue to jump to the next iteration of the loop. Generally, I hate these things because they just confuse me. And like it breaks the flow of reading code most of the time, but that's fine. No big deal here. Right, arrays in C# are smarter than arrays in C++. Thank goodness. Arrays are really nice. So if I want a bunch of numbers here, we can have an integer array, numbers equals new int of, we want like 5 numbers. Wow, so suggestion stuff is nice. So we would get at things by index. If we wanted to like assign them one at a time, we could do that. It's perfectly fine. Wow, no, those were not helpful. If I knew what the values were, I could just give them in curly brace list, right? Like 1, 2, 3, 4, 5. Look at that. Look how smart that was. 1, 2, 3, 4, 5. It's pretty handy. And so if you know the items, you can explicitly assign it here. Go for it. If you want to default them to empty, right, this will be my users numbers, then as a new int of, I don't know, 5. Sure. Now, again, we need the new keyword here, but we're not technically using a pointer. It sort of is, but it doesn't work the same way as in C++. Don't worry. We don't have pointers. We don't have to deal with that nonsense. It's a managed runtime, so when I make a variable and it goes out of scope, it gets cleaned up automatically. You still can have memory leaks, but you have to try a little harder. Like you have to keep things around. So it's a little bit smarter, which is nice here. But arrays, we know, look at this, it wants a for loop here. I love it. So now I hate I in for loops because people use i's and then they use j's, and I can't tell the difference between an I and a j. So I'm always going to say index is 0. And then we can say my users numbers dot length. So there's a length property in arrays now, which is super nice. Like vectors will tell you how long they are in C++. Basic arrays know how long they are because they should know that sort of thing, which is really nice. So we can loop then based on the array length. We'll take index plus plus. We'll ask them for a number. Look at that, users number. I don't want this one though. We'll say console.readline. Sure, and we need to convert that then, right? So we can say convert.toInt 32 int 32. Given whatever we get back from the console read line, convert. We probably need to ask them to enter a number though, right? We should output enter number or enter number. Is that makes enter number and then number or index, I guess, right? Index plus 1 because most people don't start with zeros. Like if you say enter number 0, they're gonna be confused because they're not programmers. We'll all know what they mean here, but we'll be friendly here. Enter number 1, number 2, number 3, number 4, number 5 here, and we'll go store the results here. Again, we get it stuff by index, which is nice. Great. And if I wanted to print it out, right, we could loop through again, loop by index, go for it here. We'll get to that for each loop is the fancy one. So I think you did for eaches in C++. You do a for item in a collection. Does that ring any bells? The enhanced for loop, we didn't do that? Okay, that's all right. So we'll say for each, and then we'll say int number in users numbers. I already use number. Does it not like that number? User number. Okay, it's happy with that. I must have used number somewhere else. That's weird. I didn't think I did. So the type here in some collection. And there's all types of collections. Arrays are just happen to be one collection. And if you want to save some time, you can say var. Right? For whatever it happens to be in this collection here, we'll go through and do it here. I'll just write the user's number. And not the most interesting output, but we'll go output all their numbers here. So I'll ask them to enter numbers, and we'll go spin them back out here with our for each loop. So enter number 1. What number should we have? 2. Enter number 2. 3. 23. 17. 12. All right, and we get 3, 2, 3, 23, 17, 12. Seems like it worked okay. So we can put them in an array, see them in an array, that sort of thing. Now, debug mode is really nice here as well. Weirdly, there's lots of space here. I don't know why, but if I put my breakpoint in here and run with debug mode, it will pause here and I can see the array. So I'll enter numbers here. Again, don't really matter. I'm in. Oh, I paused. That's what I was waiting for. So now I can see it's waiting to do something here with my variable list. Locals. There we go. So I can see my users numbers array here, and I can open it up and I can see the contents. Yay. Right, so the debugger now is actually pretty, and I can see the results in arrays here. The dynamic memory stuff in C++ is really obnoxious, where you can't do that sort of stuff, and I hate it. Thankfully, we aren't stuck like that though, and we can see it all. Or the view button, it'll open it up for you, which is really pretty. Like for users numbers or the regular numbers here, we can see the results. We can go change them if we want here, which is fun. We can put in numbers here. Right? Have you ever done this in the debugger? Go change values. And then when I run here, if I go step, here's my for each loop. We're going to step through. We'll get all my numbers out. And we see our output then. Where'd it go? My output go? Don't I have my window? Did it go? Oh, there it is. And we see the numbers I changed, right? Because we changed it while debugging, because we have that power, which is fun. So
Is there any way to continue the code after you put the breakpoint?
yeah, so
You have to manually.
no, you just hit continue, and it'll run to the next breakpoint or to the end. Yep. Yeah, or instead of stepping one at a time. Yep, definitely. Oh, it's just waiting for me to do more things. I'm sure we can put in numbers. Oh, there's our beep. It beeped to me. All right. So arrays are nice. Other fun things you can do with arrays is you can do essentially negative indexing. So the caret character here says from the end back one. So this is the last index here. Sure. It's just a fun thing. It's just syntactical sugar. You can take a range or copy a range out of your array. I want indexes 1 to 3. 1.3. So if I want to just get, hey, here's the some values out here. Length is nice. Different syntaxes for arrays. You can give them values. You can use the new arrays of arrays, 2-dimensional arrays, 3-dimensional arrays. If you go more than 3 dimensions, you're just going to hurt your head because I don't understand the 4th dimension. It just doesn't work in my head. And you probably could do it better with a class. Right? We probably don't need 4 dimensions, but usually 2 dimensions is plenty. Right? An array of arrays, that sort of thing. And then the for each loop and multi-dimensional arrays, the shorthand here with the comma syntax is nice as well. Instead of saying it's an array of arrays, we just give it the size this way. The syntax is kind of nice. So a couple shorthands we can do with arrays are really, really fun, working with our data. And then if we try and do bad things with arrays, let's say my user's numbers index of 6 equals a value here. I should have done this after the input. That's okay. 1, 2, 3, 4, 5. Index out of range exception. It crashes. We get the automatic bounds checking here with basic arrays. It doesn't let us do bad things. We don't have to use our vectors for that sort of thing with the at function, right? It shouldn't let us read bad memory. I don't know why C++ lets you do that. It should just crash because you don't ever want to read bad memory. It's not useful. So it crashes on us, our index out of range, which is really handy. So I will just comment that. Throws exception on bad indexes. Yay. Okay. There's arrays. Methods, we've done a little bit of methods, right? Void methods just do something. Methods that take arguments, methods that return values. And then expression-bodied methods are fun. These are our shortcut methods here that essentially let you define quickly without the whole method body. So what do we want in here? So we can say static int, how about double number? If we give an int number, we're going to use our little syntax here. We'll take number times 2, which essentially is the same thing as writing it this way. We will turn number times 2, double number, long form. Really, we should call this the short form. So if it's just one quick expression that we're doing, we can write it this way. Save a little bit of time. This is a nice little shortcut. It's all sorts of fun shortcuts we can put in here. Excuse me. Now, you can make these complex. I don't recommend it. If you're going to do something complex, don't use these expression bodies. Right? Just use a regular method. Right? You don't want it. If you have to scroll the screen left to right, you've done a bad thing. That's our general rule of thumb, right? Because the code we write is for people, right? We want people to be able to read the code and understand it. The computer doesn't care. We could write it all in one line. As long as we have our semicolons and curly braces in the right spot, the computer says, yay, this is fine. People will scream at you because it's stupid, right? We don't want to write it all in one line. So the way that we format our code is for people. So if it's really long, don't do it like this because you don't want them to have to scroll left to right. You can do crazy ternary expressions and all sorts of fun stuff, but don't. Just don't. We'll just do a regular method. Works out pretty well. And then recursion works the same way. Methods can call themselves, just like you did in C++. Recursion works out the same way as well. All right, you folks doing okay? Last chapter, and then we'll take a little break. We'll come back to talk about the first project, and then we'll call it a day. Does that sound good? I'll go over the Git process again with you once I set up all the links and stuff. So because this is a managed runtime environment, the garbage collection happens for us. So you can actually look at the .NET garbage collector. I think it was out. Where is it? I think this one's it. No, that's the docs repo. Where is it here? You can get the garbage collection method or like repository somewhere in .NET. Yeah, here's the .NET runtime. So if you want to look at how garbage collection actually works, you can go and see all the code for it. It is insane. And there's like someone had an hour-long interview with the senior developer on the garbage collection team. I got through like 3 minutes. That was it. It's like, no, this is not for me. But all of this stuff is tracked behind the scenes for you so that when a variable goes out of scope, C# says, oh, you don't need this memory anymore. We will garbage collect it for you automatically. That being said, it's not perfect. Right? It's just a machine process. It does the best it can. Sometimes it does weird things and things are slow and we have memory issues, but most of the time it's pretty good. So when we're done, we'll free it up. Right? We have the stack, we have the heap, those sort of things. Right? Method stuff goes on the stack. Generally, we'll use the heap. Garbage collector has to take care of all that stuff for us. Yeah. Most of the time here, we're looking at value equalings, not reference equalings. So if the two values are the same, they equal, rather than our two references the same. So we still have reference types and primitive types. Right? So saying an int is 42 and saying an int equals another int, I'm actually getting a copy here. So this is kind of fun, where you'll have, we have other number, and I'll have other copy number equals other number. What I get here is another double in memory. I don't have two pointers pointing at the same location in memory. These are primitive types here. When we start talking about reference types, our classes that we are generally going to use, we can have two references to the same variable in memory. For our primitive types, we get copies. Life is good for us here. It's okay. We're not going to mess them up. So passing things as variables, right? We pass copies when we're passing primitive types. If we pass reference types, then they have a reference to it and they can use that attribute or use that the variable, use the functions on it. If it's a type, we can do fun things. When we talk about object-oriented programming, we'll do a lot more examples. So not next week, but the week after. I guess we'll do a little bit object-oriented next week, but not too much. We'll look at more examples of I can pass objects, and if it's a mutable object, if you can change the object, I can use the public methods on it to change its properties. If it's an immutable object, like a string, I can't change its properties. I can still call functions on it, I can call methods on it, but it won't change the values here. So if I have, say, did you get a user's name in here? We had name here. So we'll write another method, static void, change string, given a string for some value. We'll say value equals test. Right? If I give it a string here and I change the value of it, because strings are immutable, I've only changed the copy that I have here. I've made a new string in memory assigned to test. So if I want to change my string for name here, so if I call change string given name, we'll put a breakpoint in here. Oh, there we go. So we have, where's name? Name here is Eric, right? And when we step into our method here, we now have our value string is Eric. When we change value, change to test here, value now points at a new string in memory. We've created a new string. We didn't change the original value. We didn't change what was stored where value was referencing here. So when I come back to my code here, name is still Eric. We haven't changed the original. Right? So we can't change immutable values because you can't change the value in memory. When we deal with classes and objects, we can call methods that might change them. It's a different story. So you have to be a little careful whether or not we're making copies or not. So strings can be changed in methods. Mutable. I should say they are. So that makes some difference here. So whether or not two things point to the same location in memory, if their references are the same, we might say they're equal, or two things have the same value, we might say their values are equal. This will matter when we start looking at objects and how we define if things are equal. Once we get to writing our own classes, we have to do some work to make it so we can compare them and see if they're equal or not. It's a lot of fun. All right, so I got 8 o'clock. When we take 10, we'll come back and we'll talk about the project. We'll go over the GitHub stuff again, so you'll see what the workflow is. I'll give you a quick demo of it and what it might look like, but I won't actually like do the whole thing. I'll just show you the basics so you can get started. We'll go from there, okay? All right, sounds good. See you folks in 10. Yeah.
Sometimes can be treated remotely.
811? So, project 0 here, because of course we start at 0 when we count things, because we're programmers. We're going to do a really poor federal tax estimator. I like doing this because most people know how taxes work, and I'm a little bit of a conspiracy theorist, but it's okay. That's on purpose because they don't want us to actually look at taxes and that sort of thing and write our own checks. They like when they come out of our paycheck because then we don't really pay attention to it. If everyone had to write a check every month to the feds, we'd probably be more upset about our taxes. But and that's my weird libertarian side of things. Yeah, the tax companies actually lobbied super hard to not let the feds give you a free filing option. And they ended up, you could free file certain things, but then they want to push you into buying other services when all they need to do is be like, I think you owe, and you say yes. Or if you don't, if I have more deductions. It's a whole other, okay. Anyway, taxes are fun. So the way that taxes work is we have a progressive tax system. So which the bracket in which they're earned. So if you make two, and these are for if you are single, you'll use the single brackets. If you're married, you'll use the married filing joint brackets most of the time. Again, it's a little funny here, and there's a bit of a penalty, which sucks, but that's okay. My wife stays at home, so we don't hit that penalty. It's okay. So the first $10,275 that you earned in 2022, you paid 10 cents of every dollar in federal income tax before credits and all sorts of other tax policy stuff. And that's a whole other story. This is just a bad estimator. So for every dollar between 0 and 10.275, you pay 10 cents on the dollar. For every dollar you earn up to 41,000, that's more than 10,275, you pay 12 cents on the dollar, and on up. So as you earn more money, you pay a larger percentage as you earn more money. So just because someone makes 100 or 500, I would say $600,000 a year, does not mean they pay 37% of that income in taxes. Doesn't work like that. They pay the bracket level up to that income. They're only paying 37% on the money between 539,900 and 600,000. Okay, this is a weird concept for people. It's okay. I once had a student tell me he talked to his dad about it, and his dad said I was wrong, and I just laughed. Why go tell mommy on me? I don't know. And they was wrong anyway. So I sent him IRS links and never heard again. Like, okay, sure. That's fine. So this Money Chimp site is actually pretty handy. It gives you a nice little breakdown here. Like, hey, because you pay taxes at the bracket, you're doing some arithmetic here. So this is a good, quick little example for you to do some arithmetic in C#. It's not too bad. We're going to use different loops here as we go. So we'll ask them to we'll say, how many W-2s do you have to enter to calculate gross income? So generally, most employees, we are direct employees, we get W-2s because our employer already takes taxes out for us. We're not self-employed. We get all sorts of other tax policy nonsense reasons. That's fine. We'll say, hey, I have 3 W-2s. I teach here, I teach there, and I have a day job. Sure. So I'm going to enter 3 W-2s. So the program will say, okay, enter the gross income from the first one, enter the gross income from the second one, enter the gross income from the third one. I'll enter those values. You should total it up for me. That is my gross income. That's the total amount of income I've earned in the year. Then we'll say, okay, for deductions, just enter deductions until you're done. A different kind of loop, right? A loop with a sentinel value or however you want to do this. We'll just loop until they're done because I don't want to have to flip through all my charitable deductions and say, I have 27 deductions to enter. Just let me enter numbers and I'll tell you and I'm done, right? Either you use a particular numeric value, like I probably don't have a deduction for -$1, right? Like, sure, we can use a particular value, or you can say, do you have more to enter, yes or no? And if I enter yes, ask me again for another one. Sure, that's fine. Total up my deductions. If it's less than the standard deduction, I get the standard deduction because we have our progressive tax policy again says, we'll just assume we can write off a bunch of initial values. That's fine. If you donate more than this to charities and other sorts of interesting stuff, you can claim them individually. That's perfectly fine. So we technically incentivizing charitable donations, although for a lot of people, this is a very large number. Depends on how much you're donating to charity. Especially for married couples now, you got to hit like 25 grand worth of charitable deductions. It's pretty steep. So most people will take the standard, but again, it makes life easy and it gives a more progressive tax system. So the people earning the most money, right, are paying more in taxes because you get to not pay taxes on the first amount here. Again, our poor estimator says our adjusted gross income is the gross income minus your total deductions, whether or not it was the standard or not. If I donated nothing to charity, I still get to write off $12,950 worth of income. Now, technically, we have negative taxes and you can get money back without paying taxes. Just don't pretend that doesn't exist. We're just doing a bad calculator here. It's okay. So at most, you'll owe nothing in taxes. And we'll forget that we have credits for all sorts of things here. The tax policy is complex and crazy, and it's a whole system for the tax lobby industry and that sorts of things. I'm not biased at all, I promise. But sure, so we'll say at most your total, or at least your adjusted gross income is zero. Can't go negative. You're not going to get money back even though you can in the real world. We'll just assume it's zero. And we're going to display taxes owed at each bracket, even if it's $0. Like this Money Chimp site says, okay, sure, your taxes you owe at 10% are this much. Taxes you owe at 15% are this much. And this is actually one from 2012. They just never updated their website because I don't know why. They update the other stuff, but that's okay. So all the way up through the 37% bracket, tell them, hey, you paid no taxes at 37%. It's perfectly fine. Most people don't. It's okay. We're still going to display it. Then we'll also display the total taxes owed, the taxes as a percentage of gross income, and taxes as a percentage of adjusted gross income. Okay, we'll just calculate those numbers. They're basic arithmetic. It's not too hard, I promise. You don't need to make your output look pretty. I don't care if it has 15 decimal places, right? The formatting stuff we can worry about later. It doesn't need to look nice. We'll just make it work, okay? And again, warning, we will do this again next week with a form application where we have buttons and text boxes and things. So if you write all of your logic in the main method, it's going to be a lot of work to rewrite it. If we make a class here or have some functions that take values and give me results back, life is a little easier to copy and paste that into the next project without having to change things here. So if you do it all with methods, it works really easy. We just use the exact same methods. If I have a method for calculate taxes owed at 10%, here's my income. We're done. Right? I can use that exact same method, whether or not it's using console input and output or using a form for a graphical user input or not. Right? So we want to think about how we make our programs portable and reusable and changeable like that. When you use values here, there's a cool thing I forgot to show you here. When you have numbers here, so double or just an integer, some big number equals like 1,236,987. You can put as many underscores as you want in here. C# ignores them. We like them as digit separators. If you are a mean person, you put them in random places here to just piss off other people. I don't recommend this, but you can. C# doesn't care. Again, as long as you follow the rules, C# will do it. The code we write is for people to look at and read. So we want to follow good conventions and name things nice. So variable names start with lowercase letters. Method names start with uppercase letters. Camel case everything. Some people like the snake casing. That's not a big popular way of formatting things in C#. And it actually will format the stuff for you here. If you go and do edit and advanced, you can format your document here. It's my format document. And we'll align everything for you, those sorts of things. There are other tools we can use that will automatically rename stuff for you, which is really nice and pretty. I don't bother with them most of the time. There's other things we can do. When using source control tools, they can be automatic checks, and there's all sorts of cool bells and whistles we can do, but we just don't really have time for all of them. So I would encourage you to use underscores for your values here. Use variable names, not literals. Anytime you have just a number randomly in your code, we'll call that a magic number if it doesn't have a variable name assigned. The variable name tells you what this number is for, right? So if I have, tax top of tax bracket at 10%, I know what that is. I don't just have the number, I don't even know what the number is here, 10,275 literally in my code. And then if I need to go change this for 2023, next year, if I want to use my same income tax estimator, because we just change a couple values and charge people $100 for it again because we're the tax industry or tax filing industry and just take people's money. Sure, I change a couple values and we're done, right? And we just make money, we just profit. That's the goal, right? So we want to make it easy to change. So if you have a variable name, you can go change that variable one time rather than every place it is in your code. Now, you can do find and replace, but it's failable, right? It's better to have variable names that mean things, right? So we assign them. We don't want those magic numbers. So what you're going to do then, so I think I've got this ready to post here. You have a link here at the top. This is the GitHub Classroom link, classrooms.github.com/something. When you go here, it will ask you either to log in or to accept the assignment. If you're not logged in, log in first and then accept the assignment. So it will make a repository for you that's a private repository that you have access to and I have access to. And then our grader will have access to. I'll add them to it as well. You'll say accept the assignment. It says, great, I'm going to make your repository. It might take several minutes. It takes like 3 seconds. So by the time I'm done talking, I refresh the page. I'm good to go. The template we use is super basic. So there's not really a whole lot of stuff there. You can do some cool things with these repositories that I just don't I haven't done. So now I can click the link. Takes me to the repository. This one has this little lock icon. It is a private repository, right? You'll notice that little lock there. Please don't make your own repositories for class assignments because most of the time they won't be private. And if it is private, I won't have access. I'll be sad, right? So use the classroom ones. Now we have a repository. It's just a folder. My computer doesn't have it yet. So I'm going to click the green code button and say open with GitHub Desktop. I'll say, do you want to open GitHub Desktop or do you want to install GitHub Desktop if you haven't yet? You can go install it. It's desktop.github.com or it will tell you where to go. You say open. It says, okay, what do you want to do? Here's the repository. Where do you want to put it on your computer? It likes to put things in your documents GitHub folder and then the name of the repository. Defaults are great. Again, if you want to put it somewhere else, put it somewhere else. I don't really care. I will see it on github.com. I'm not going to see it on your computer. So however you like to manage your files, go for it. We'll say clone. It takes a few seconds, makes a copy of that folder on your computer. Now I can do show in Explorer and I can see the folder here. So if you ever don't know where your repository is, just say show in Explorer and take a look at your path here. Right? We can see it's in my C users, Eric C, documents, GitHub, CIS 297, winter 2023, project 0-Eric Janeski. So this is your GitHub username, shows up here. So everyone's repository is unique because everyone has to have a unique username. Works out pretty well. Here's the folder. In this folder is where I'll make my project in Visual Studio. So do this step first, then go to Visual Studio and start your project. If you start your project first, it won't be in the GitHub repository and you won't be able to commit and push your changes. You'll be sad. Okay. Now I can go back and make a new project. Again, you want a console application, not console application.NET framework, just a basic console application, and go find the folder. Don't do it in source repos. Go browse, find your GitHub folder, find your project folder, and say, okay, name it something. Like Project 0 is probably a good name for it. I don't really care what you call it. Just, again, it's just folder names here. It doesn't really matter at all, but it's nice to organize things nicely. We're great. We'll say next. If you want to use top-level statements, great. If you don't want to use top-level statements, great. I don't care. They'll both work perfectly fine. Either's up to you. We'll say create. Now I've got the starter code here. If I come back to the GitHub client, if you see the files here, you've done the right thing. If it doesn't show new files, you didn't put the project in the right spot. Try again. Okay? Just go back, go view the folder, find where the folder is, go browse and find that when you start your project. So if you get to here, here's like project started, commit and push, you're good to go. Once you've pushed, go view on GitHub. Make sure you can see it on GitHub. So you can open up your Project 0 folder, open up Project 0 folder again, open up your CS file. Make sure it has your last version of the code, latest and greatest code. If you've committed and pushed, it'll be out here. If you can see it on github.com/Chernesky/something, I'll be able to see it there. If it doesn't say github.com/Chernesky, I won't be able to see it most likely, unless you've done some extra work. Again, avoid that. Do the easy thing. Use the repository the GitHub Classroom thing does for you. So github.com/Chernesky/CIS297 winter 2023 project X, whatever, your username. If you can see it there, I can see it there. When you're ready to turn it into Canvas, copy paste this URL, come in here, go to your submit box and hit push or turn it in. It should ask for a URL if I did it right. I think I did, yeah. You want to submit a website URL. You'll be good to go. Okay, so I need to build a rubric for you real quick. So let me do this. This is for project 0. So we get using GitHub workflow. So just by doing the right workflow, if you just turn on an empty project, you can get 2 points out of 10. Don't use file upload. If you use file upload, you don't get these 2 points. I hate file upload. Don't use it. Okay, just use the workflow. We have the workflow for a reason. Okay, and then we have our loop for W2s. 2 more points. We have our loop for deductions. Great. 2 more points. And then taxes calculated at each bracket. 2 points. And then last 2 for total taxes as percentage of gross income and adjusted gross income. GI, AGI. Is it okay if I say GI and AGI? Gross income. Okay, I'll spell them out. I feel bad now. I say variable names should be meaningful. And adjusted gross income. There we go. 2 more points for that. So that's 10 points. Very first project. When we go to score these things, we just check, yes, you did it, no, you didn't, or it was there but didn't really work as partial. I'm happy to give partial points here. Okay. Not a hard project, I promise. Okay? It won't take that much time, but we'll give you a chance to exercise some of this stuff in C#. We'll do some loops. We'll do some calculations. We'll do a bunch of FL stuff. We'll work with values here. Pretty basic, easy start here. Next week, we'll come back, look at all the Windows Form stuff, look at Maui, look at XAML, build a graphical user interface application, which is much more fun than these console applications because very few people like type stuff into the console. This is a really old way of doing things, but we got to start with easy stuff before we do the hard stuff. So then we'll build a graphical user interface application that does the exact same thing. I can enter my W-2s, I can enter my deductions, I'll get the exact same output here, but it'll be in a Windows form that I can click on, and everyone likes to click on buttons and things and type in text boxes instead of typing stuff into the console. Okay, so think of that when you design it. Methods are great. You can reuse your methods. They copy paste really nicely for you, and life is pretty good. Okay, so that's the GitHub workflow. When you go submit it, right, you just paste in the URL here of your project. If you got questions, you can send me the URL. You'll say, hey, I'm having trouble with my code. I'm getting a weird error. I'll ask if your code is on GitHub. I'll say, send me the link. We can go from there. You can reach me over email. You can text me. You can find me on Discord. I think Discord's usually the easiest because then we can screen share right in Discord. We can set up Zoom meetings to screen share. Happy to do all that. Don't come next week and say I didn't get it to work. I'll be really sad. Like, if it's not working for you, ask me. Okay? I'm happy to help get you at least started, get the right process going here. I'm not going to tell you to go away. I have a class on Thursday before this one, so don't wait until Thursday at 2 p.m. to say, Eric, I didn't get it to work. Okay? Can we do that? All right. I got office hours usually on Thursday before class over in the ELB. Happy to chat about that. It's a little hard to solve problems for a project that's due in like 2 hours. So let's try not to use that for project problem solving. But other stuff is perfectly fine. Always happy to chat. We can play games in there as well. We got Xboxes to play on, PlayStations, other fun stuff. We got some VR things set up in there too. I have a HoloLens. If you like augmented reality stuff, we can play with, which is pretty cool. We'll go from there. So it should be a fun semester. Look forward to it. If you got any questions, let me know. Take care, everybody.